Hello ladies and gentlemen, we are going to go over the Unit 4 review for Unit Test 4, Advanced Algebra through Data Exploration. Alright, here we go. There is some evidence that drinking moderate amounts of wine helps prevent heart attacks. The table gives data on yearly wine consumption. This is measured in liters of wine, alcohol from drinking wine per person, and yearly deaths from heart disease, and these deaths are measured per 100,000 people in 19 developed countries. All right, so when we're looking at this, we see that Australia, it's 2.5. Now that's 2.5 liters. And the heart disease deaths is 211 out of 100,000 people. Okay, so keep that in mind as we are looking at this problem. So the first thing we're going to do is figure out the explanatory variable. Okay, the explanatory variable would be alcohol from wine. The response would be heart disease deaths. As I mentioned in previous videos, at any time you can pause it if I'm going too fast. Okay, the next thing we're going to do is we're going to make a scatter plot that shows how wine consumption affects heart disease. Label the X and Y axis. Numbers are not needed. Sketch the graph. Alright, so what we're going to need to do is we're going to need to enter the numbers into list 1 and list 2. So, in list 1, we are going to put the alcohol from wine. Okay, so when we get down to the bottom, we're going to need to go over here and continue in list 1, alcohol from wine with the Netherlands. Same thing with heart disease deaths. You're going to have to put those in list 2. When you get to the bottom of that list, you need to go over here and type those in also for list 2. So list 1 will be alcohol from wine. List 1 will be alcohol from wine. List 2 will be heart disease deaths. Alright, so what we're going to do is we're going to type those into the calculator. Now, I have already preloaded those into the calculator to save some time. Okay, so I already have them in. So if you are going to need to type them in, you may want to pause the video at this time. So, after we have them typed in, okay, hopefully our calculator is ready. All we need to do is hit zoom 9. And there's the scatter plot for this problem. Alright, so we're going to sketch that. So again, I've already preloaded this on, so I can sketch it very quickly. Alright, there we go. I'm going to label the bottom of my graph. Okay, the bottom of my graph is alcohol from wine. And again, that is measured in liters. And on the side, we have heart disease deaths. And again, that's measured out of 100,000 people. Okay, the next question, what type of correlation is it? Okay, the dots are going down, so it is a negative correlation. Describe the relationship. So we say as the alcohol from wine increases, the heart disease deaths decrease. Okay. Next page. All right, well, we've already done this. Type the data into your calculator. What is the correlation? All right, so in order to get the graph, we had to see we had to type the data in to see the graph. So we need to now do stat calculate. Okay, remember this one is number 4. Stat calculate number 4. All right, so the question is the correlation, which is the R value, and we can see the R value is negative 0.85. So R equals negative 0.85. And if you remember, this is very strong. It is a very strong relationship. Okay, what is the equation for the least squares regression line? All right, well, that's also on the screen that we just looked at, so let's go back. We see that A is negative 24.7. I'm going to go ahead and go to the 0.7. You could round it to negative 25 if you wanted. And I'm just going to round B to 270. So my equation is y equals negative 24.7x plus 270. Okay, and remember, x is representing the alcohol from wine, and y is representing heart disease deaths. All right, I am going to, before I interpret, I'm going to type this equation into my calculator. So I'm going to go to my y equals. Okay, I've already preloaded it in there. So I type that into my calculator, negative 24.7x plus 270. I'm going to hit the graph button, and the line is going through the dots. So I'm going to go back to the first page, and I'm going to, as closely as I can, draw that line through the dots. Now remember, this is called the line of best fit. It is called the least squares regression line, and it's also known as the line to predict things. Okay? The best fit line. It helps us to predict. So going back to the first page, see how accurate I can do this. It looks like the line, let me make this a little bit thicker. Green. All right, so it looks like it's kind of going like this. Okay, let me take a look. Well, pretty close. Okay, close enough. Same thing on the test, just get it as close to that spot as you can get. All right, going back. Now, the challenging part is let's interpret the slope. Now, the slope is the number in front of x. And x is representing alcohol from wine. Okay, so we are going to start off, since the slope has a whole number in it, we're going to start off with just 1 unit of alcohol. And that 1 unit would be liters. So here we go. So we say, for every 1 liter of alcohol from wine, heart disease deaths decrease by about 24.7 per 100,000 people. So for every 100,000 people, there are 24.7 fewer deaths. Okay? Again, for every liter of alcohol from wine, heart disease deaths decreased by about 24.7 per 100,000 people. Okay, now the y-intercept. The y-intercept is the 270. So I'm going to go back to the graph. The y-intercept is right here. That's the 270. If we go down to the corner, that will be a 0. Okay, well, 0 in this case means they don't get any alcohol from wine. Okay, so this y-intercept actually is going to make sense, not like the others we discussed in class. Okay, so this y-intercept makes sense. So, in a country where 0 liters of wine are consumed, we can expect 270 deaths per 100,000 people Okay, in a country where 0 liters of wine are consumed, we can expect 270 deaths per 100,000 people from heart disease. That totally makes sense. Okay, there are some countries where alcohol is not permitted. Okay, so they may have a higher death rate for heart disease per 100,000 people. Okay, the next part. Use the least squares regression line to predict the heart disease deaths per 100,000 in a country that consumes 10 liters of alcohol per year from drinking wine. Okay, I'm going to rewrite my equation down here. So y equals negative 24.7x plus 270. All right, so I am going to go ahead and plug in 10 liters of alcohol. So negative 24.7 times 10 plus 270. You can go ahead and type that into your calculator and you're going to get 23. So what does that mean? That means 23 deaths per 100,000 people. Okay, now determine the residual for Canada and New Zealand. Now, just a reminder, when we did the stat calculate number 4, when we did this process, the calculator has already figured out the residuals. We just need to go find those residuals. All right, so here we go. So here are the steps. So we go back to our list. So stat edit, go to the top of list 3. Whoops, I cleared out the wrong one. Let me do that again. Okay, let me go to the top of list 3 and clear it out. Now go back to the top. You got to be all the way to the top. Now to find the residuals, we do second stat and we look for the word resid. Okay, and my resid is up here. There it is. I'm going to hit enter twice. Okay, there are my residuals. Now, I need to find Canada and New Zealand. So I got to go back to my paper. I got to go back to my list. Okay, and I need to look for Canada. Okay, Canada is 1, 2, 3. It's the 4th country. All right, I'm also going to locate New Zealand really quick. So Canada is 4, 5, 6, 7, 8, 9, 10, 11, 12. So I need to go to the 4th country and the 12th country. All right, let me go back to this page. I'm going to find the residual And remember what a residual is. The residual is the distance from the line to the dot. If the dot is above the line, it's a positive residual. If the dot is below the line, it is a negative residual. All right, so now I'm going to go back to my calculator and I'm going to go to the fourth country. So again, look in the bottom left-hand corner. There's the fourth country. So I'm just going to say negative 20. I'm just going to round it to negative 20. So Canada is below what it should be. It's 20 liters or 20 deaths below what it should be. Okay, New Zealand, again, was the 12th country. So I'm going to go back to my calculator. Again, look in the bottom left-hand corner. I'm going to go to 12, 9, 10, 11, 12. And I'm going to round that to 43. Now that is above the line because it is a positive residual. All right. Okay, let's continue. Next page. All right, the AP Statistics exam was first administered in May 1997 to the largest first-year group in any discipline in the AP program. Since that time, the number of students taking the exam has grown at an impressive rate. Here are the actual data. Begin by entering them into your calculator. Now, use your calculator to construct a scatter plot for these data, using 1997 as year 1, 1998 as year 2, and so on. So when we enter this into the calculator, we're not going to enter the year, okay? We're going to enter 1 for the first year, 2 for the second year, 3 for the third year, and so on. And then the number of students in list 2. Okay? So I'm going to go ahead and pause this and put them into the calculator. Okay, I preloaded these into the calculator, so I have them typed in already. All right, so the first thing we need to do, let's go back to the paper. What is the explanatory variable? All right, well, in this case, it will be the year. The year explains the response, which is number of students. Okay, I'm going to just go ahead and put those down on my graph already. So I'm going to put year here. Again, numbers are not needed, just a sketch. And number of students. All right, I'm going to make the scatter plot. So I am going to go ahead and, again, I typed them in list 1, list 2. I'm going to go ahead and do zoom 9. And voila, wow. That almost looks like a perfect linear relationship. All right, so I'm going to go back. Again, I already preloaded this. So I'm going to go ahead and put this on my graph. There we go. Again, you can pause it at any time. All right, make a scatter plot, done. What type of correlation is it? Well, that obviously is positive. Describe the relationship in words. Okay, as the years increase or go up, the number of students taking the AP Stats test increases. Okay, what is the correlation? All right, calculator time. Stat Calculate. Number 4. Wow, the correlation is 0.999. Okay, I am not going to round that to a 1, so I'm going to write this as 3 decimals. So R is 0.999. Okay, it would not be appropriate to just put 0.99. Okay, so go 1 more decimal. And again, that is very strong. Okay, the next page. Our equation. So y equals, okay, the a value, we're going to round it to 8,489. Followed by x. And the b value is negative 946. So I'm going to put plus negative 946. All right, what does x mean? X is the year, and y is number of students. All right, now, real quick, I'm going to go ahead and put that equation into my y equals. As you see, I've already preloaded it. I type it in, I hit graph. Oh, what a wonderful picture. Isn't that beautiful? It's a work of art. Okay, the line goes through the dots, really nice. I'm going to go ahead and go back and put my line through those dots. All right. Again, remember that is our trend line. That is the line of best fit. That is the least squares regression line. And that line is used to predict. All right, so let's interpret. So the slope is this. And the x is representing the year. So, now, it's a whole number in front of it. The slope or the rate is a whole number. So we're going to just use the number 1. Or instead of the number 1, I'm going to say each year. Okay, so each year, which means 1 year, every year, each year, 8,800. Okay, make sure I type that right. Okay, I wrote it wrong. Whoops. Made a mistake. Maybe you caught it already. Okay, hold on. It's 8,489. My apologies. Okay, go back and fix that slope if you wrote what I wrote. Okay, it's supposed to be 8,489. So let me fix that. Okay, so 8,489. So each year, 8,489 more students take the AP Stats test. All right, interpret the y-intercept. All right, the y-intercept is right there. I wonder if this y-intercept's going to make sense. I'm going to go back and look at the picture. So the y-intercept is right here, and I know that looks a little weird, but that's supposed to be negative 946. And down at the bottom here, that's a 0. Okay, I don't think this makes a whole lot of sense. Okay, so year 0, this is what it's saying. Year 0, which there can't be, there were negative 946 students who took the AP Stats test. Well, obviously, that's impossible. So this is a y-intercept that does not make sense. Okay, the first one did, but this one does not. Okay, truthfully, in year 0, there were 0 students who took the test. Okay, but according to our equation, that's what that is. All right, use the least squares regression line to predict the number of students who will take the test in 2014. All right, so y equals 8,000, make sure I get this right this time, 489x plus negative 946. Okay, but hold on here. I have to figure out what number to use for 2014. 2005 was the number 9. That means 2006 was the number 10, 7 was the number 11, 8 was the number 12, 9 was the number 13, 10 was the number 14, 11 was 15, 12, 16, 13 was 17. Oh, 2014, we have to use the number 18 because that was 18 years later. So we're going to plug in an 18 into that equation for x. So here we go. So 8,489 times 18 plus negative 946. That's a lot of students. 151,856 students. Okay. Determine the residual for 1999. All right, well, first of all, let's get the residuals loaded into our calculator. So again, we're going to go back to our list, or our stat edit. We're going to go clear out list number 3. We're going to go to the top. We're going to go second stat. We're going to go find the word resid. There it is. I'm going to hit enter twice. There are my residuals. Okay, now I need to figure out what 1999 is. So I'm going to go back to my table, or back to my paper and look at my table. So 1999 is the 3rd year, and 2004 is the 8th year. Okay, so 1999 is the 3rd year, and 2004, again, was, I believe, we just said the 9th year. Let me go back and double check that. Nope, the 8th year. I'm silly. Okay, let me go fix that. It's the 8th year. All right, the 8th year. All right, so on my calculator, I'm going to go to the 3rd year, 2, 3. Wow, that's way above average. We're just going to say 719. And the 8th year, so we're going to go down to the 8th year. Oh, in that year it was below average, negative 1,088. So more students than average took the test in 1999 because that dot is above the line, and fewer students than average took it in 2004 because it's negative 1,088. All right, next page. Use the following graph to answer each question below. What type of correlation is it? Okay, well, the dots are going up, so it is positive. Describe the relationship. Well, I see the bottom is the year. This is dealing with baseball tickets. So this is the year, and on the side is the average price. So I'm going to say as the years increase, baseball ticket prices increase. All right. In 1998, the average baseball ticket price was less than $14. Okay, so let's see. 1998 was less than, okay, so here's 1998. Here is the ticket. It's below or less than $14. Is that price above or below the predicted value? Well, that should be easy to see. The dot's below, so we're going to say below. Okay, so why? Explain. The dot that represents the actual price is below the line. Okay, the next one. In 2000, the average baseball ticket price was about $17. Is that price above or below the predicted amount? All right, so 2000 is right here, and here's the dot, which is above the line. So we are going to say above. So, explain. The dot that represents the actual price is above the line. E. What is the approximate predicted average price for a baseball in 2004? All right, back to my graph. So here's 2004. I'm going to go up till I get to the line. Boom. Okay, again, it says, what is the approximate predicted average price? Not the actual, but the predicted. Okay, so I go to the line. Now I'm going to go across right about here. Okay, so it looks like it's between $20 and $22, so I'm just going to say 21 because, again, it's just about. So we're going to say about $21. Next question. What is the predicted average price for a baseball ticket in 2006? All right, so again, I'm going to go up to my graph. Here's 2006. I'm going to go up to the line. Boom. And I'm going to go across. Boom. Looks like about $23 to me. Okay, so about $23. All right, moving on. Use the following graph to answer the questions below. What type of correlation is it? Well, the dots are going down, so it is negative. Describe the relationship. So the bottom is time since purchase in years, and this is dealing with used car values, and on the side it is the value of the car. So we're going to say, as the car gets older, because that's what's happening, so as the car gets older, the car value decreases. And we already knew that from previous problems that we have done. All right, so we're going to use the graph to help make some predictions. Predict a car's value for a car that is 4 years old. All right, so I got to go to 4 years. Here it is. Here's 4. I'm going to go up. I'm going to get to the line. Boom, and I'm going to go across. And I see an 8. Now, ladies and gentlemen, you'll notice it says in thousands of dollars. So we're going to say about $8,000. What is the approximate predicted value of a car that is 12 years old? All right, go to 12, go up, boom, and across, and oh, that's easy, that's $2,000. So about $2,000. All right, almost done with this part of the review packet. A car is worth $5,000. About $5,000. How old is it? Well, we got to go do that a little bit different. So here's 5,000 on the side of the graph. 5,000, I'm going to go across, boom. I hit the line, I'm going to go down, boom. Oh, that was easy. That's about 8 years old. Okay, one more. Worth about 9,500. How old is it? All right, so let's see. 9,500, that's going to be in the middle, right here. 9,500, right here between 9 and 10. I'm going to go across, boom, hit the line, go down. Looks like 2 years old. So about 2 years old. Now, again, some of this test that you're going to be taking is multiple choice. So be aware you are going to have multiple choice in these situations. All right, let's do the review part. You will be happy to know the review part is what we have already done once already this year. Oh, look at that. Explicit formula. It comes back. All right, we had a mastery quiz on this stuff also, so you should remember it hopefully pretty well. So, find the explicit formula for the arithmetic sequence. Remember, that means we're adding. So here we go. We see from 4 to 7 is up 3. So that means we would go up 3 again. So that must mean that that's 10. Up 3 again. That must mean the next number is 13. Oh, we see that right here. All right, going backwards. Well, that would have to be a 1. Okay, going backwards, 4 take away 3 is 1, and then you can see 1 plus 3 is 4. All right, now explicit formula. This is where we do the u sub n. Okay, now the pattern is 3, so the next number is 3, followed by the letter n, plus the number under the 0. Again, this is arithmetic. So u sub n equals 3n plus 1. The next one is geometric. Geometric means we're multiplying. Okay, so if you cannot figure out what we're multiplying by, remember, go backwards. Take 6 divided by 2, which is 3. Okay, that was pretty easy. So we're multiplying by 3. Okay, 6 times 3 is then 18. Yep. And 18 times 3 is 54. Okay, go backwards. Well, if I'm going backwards, I'm going to not multiply, but I'm going to divide by 3. So, and I'm going to leave that as a fraction. So I'm taking 2 and dividing it by 3. Okay, I would rather see a fraction than a decimal there, because this is a repeating decimal. Now, since this is geometric, the number under the 0 is first, parentheses 3, and the exponent is the letter n. Do not get your arithmetic and geometric sequences mixed up. Moving on. Use the explicit formula to find u30. Okay, all we do is substitute. 5 times 30 plus 6. 5 times 30 plus 6 is 156. Substitute for n. Find the 20th number in the sequence. So 10 times 2 to the 20th power. 10 times 2 to the 20th power is a very large number. Okay, 104, 85, 760. If I put commas in there, that would be 10,485,760. Okay, 2 left. Okay, find the, remember this symbol means sum. Find the sum of this sequence from the first number in the sequence to the 35th number in the sequence. So the first thing we need to do is, what is the first number in the sequence? Okay, so we plug a 1 into our rule. And we find out that that is -2. Then we need to find the 35th number in the sequence. So I take the 35 and plug it in. Okay, when I plug that in, I find out that the 35th number in the sequence is 66. Okay, I now have all my pieces of information that I need for my formula. Okay, the 35 is the n, that goes right there. The first number in the sequence is -2, and the last number in the sequence is 66. So we write 35 times -2 plus 66. Close it, divide by 2. Type that into the calculator just like you see it, and you get 1,120. All right, last problem. Okay. Now, well, let me back up. Let me go back up here. So this, ladies and gentlemen, is representing an arithmetic sequence. Okay, 2n minus 1, that's arithmetic. This one right here is representing a geometric, so the formula is different. So in this case, all we need is to know the first number in the sequence. So we're going to find what's the sum of the 15 numbers in this sequence. But all we need to know is the first number. Okay, so 12 times 2 to the first power, which is 24. All right, so the first number in the sequence is 24. The rate, that's what's inside the parentheses. That's your rate. There are 2 of them. So we're going to put a 2 on the top and the bottom. Okay, and then the last thing is, what is the n? Again, the n is the top number, so the n is going to go right there. So that is going to be 2 to the 15th power. Now that's inside the parentheses. Type that into the calculator very, very carefully, and you should get 786,408. All right, that is the review for Unit 4 test. Good luck. See you later.